Welcome to the walkthrough for Lab 7. So I'm going to go over questions 10.10 and 10.11. 10.14 you're going to do on your own, so I'm going to really test you to see if you understand the concepts. Again, it's going to be the same setup, it's just you're conducting two different tests. So 10.10 and 10.11 we're going to go over right now. I also posted a Word document on Beachboard highlighting these same steps. Again, if you've already done the assignment, you're good. If not, it's another way to just follow along. So here we're going to be conducting a z-test. So you guys are talking about this in class right now. Again, use your resources, use the videos posted, as well as your textbook. This will help you complete this assignment. So z-tests are basically used when you have a large sample, and we do it when standard deviation is known. Now for our first question, we have a question right here. It's looking at a satisfaction survey, and basically you have your null, you have your alternative. Your null is your original statement, your alternative is what you're trying to test. So here, our null hypothesis is our satisfaction rate equals 90%, and what we want to test is, can we infer that the satisfaction rate is less than 90%? So that's our alternative, that's what we're trying to test. So in order to do this, you need to calculate a couple things. For each one of these problems, you need to set up a null and alternative. If you don't, you will get docked points. Again, this is something you should get used to doing in the lab as well as lecture. So to start, we need to calculate p-hat. P-hat is your sample proportion. This is basically showing you out of your population or your sample, how many people either said they're satisfied or unsatisfied. So we're trying to look for satisfaction. So the code for p-hat, I'm just going to put in here. It's going to be equals. Now the code that we're going to use is count if. Again, we've used this multiple times. You can look at your previous labs. Now our range, it's given by here, so Control Shift down. And then our criteria is going to be 1. Now we're looking at people that are satisfied. So we're looking at individuals that are satisfied, and again, this is our p-hat, so we have to divide this by our n. Now in order to do that, you just divide, and you're going to use a count command and use our range, and you hit enter. Alright, should not be doing that. So you should get 0.86. So 86% of our population, or our sample in this case, is satisfied. Our claim is 90%. So you can already kind of see where we're going. Our P in this case is going to be our satisfaction rate, or what's given to you by the problem. So in this case, it's going to be 0.9. Now our Z value. So Z value is where I provided a formula on the Word document. If you have, you can follow along with it. So you have your p-hat, and you subtract it from your p. So your p, this is what's given to you by the equation, or by the question, and your p-hat is given to you by your calculation, so what we calculated. So make sure you use correct parentheses. It's going to be p-hat subtracted by your p, and you're going to close the parentheses. And you're going to divide by the square root, SQRT. Now make sure you use your parentheses correctly. So what I do, I just do double parentheses. It's going to be your P multiplied by 1 minus your P again. Close the parentheses. And then you're going to divide by your count. Alright, so now if you look at our code, this outer white parentheses is including everything in the square root, and you're just going to hit enter, and you should get negative 1.5784. So you've calculated your z value, your p-hat, your P. Now what we want to do is calculate our p-value. So in class you will be asked to calculate p-value for the exam. For the finals it might be p-value or your z-value. In this case, for this lab specifically, we are going to calculate p-value. So the formula for this is norm.dist. Now your x value is your calculated value that you were given. Our mean is 0 and our standard deviation is 1. Now it's because we use 0 and 1 because we're assuming that it is a normal distribution. Anything that has a normal distribution has a mean of 0 and a standard deviation of 1. Now cumulative, you're always going to put true. You're going to hit enter and you should get a value of 0.057. Now when you get this value, you're always going to compare it to alpha. Now in class or in lab I mentioned if alpha is not given to you, you're going to assume it's 0.05. And now we're going to compare these two numbers, 0.57, or if you want to round up, 0.6 to 0.5. Now the rule of thumb, if your p-value is greater than alpha, and if your p-value is less than alpha, these are important to know. So when your p-value is greater than alpha, you fail to reject your null hypothesis. So you fail to reject your null in this case. Now if p is less than alpha, you're going to reject the null. So again, these are your rejection regions. You can do this with your critical value as well if you compare it to 1.96 or negative 1.96 or 1.645. But in this case, you want to compare p-values. So you're comparing this to your alpha. So if your alpha is not given to you, which it's not in this question, it's going to be 0.05. And then you base your decision off of this, and you're going to provide an explanation. So can we reject or do we fail to reject in this case? Now 10-11, again, very same setup. Here we're trying to see so does the data allow us to conclude at the 10% significance level that more than 50% of all business students would rate the book as excellent? So excellent is 1. So again, we're going to use the COUNTIF command. It's the same setup. Now our new alternative and null hypothesis is, our null hypothesis is it equals 50% or it's greater than 50%. So again, keywords that give it away: more than, it's going to be greater than. So p hat, the code for this, it's going to be equals COUNTIF comma, it's going to be 1, close it, and then it's going to be our count command. A3 to A102. You're going to hit enter, and you're going to get 0.057. So this is your sample proportion. So out of all of these students, 57% of these students think that this textbook is excellent, or they rate it as excellent. So our P in this case is given to us by our equation, or by our question. So it's 0.5. Now we want to calculate our Z value. Again, the formula is on the Word document. It's, again, use your parentheses. It's P hat subtracted by your P given to you by your function, and you're going to use your square root. Make sure you put your parentheses. So it's going to be P multiplied by 1 minus P divided by, you can use count or you can just use 100. Again, 100 is given to you here. You're going to hit enter, and you're going to get 1.4. That's your Z value. Sample size, it's just 100. It's given to us. Now our P value. Here, we're going to use our norm.dist. Now reuse our z value, mean of 0, standard deviation of 1, and it's going to be true. We hit enter. Now you get a value that's much greater than your p-value. So one thing that you should do, it's going to be 1 minus your norm.dist. And you should get a value of 0.08. Now you'll talk about this in class, why it's going to be 1 minus and why this value is, we're looking at the left-hand side tail of this test or the right-hand side. Our explanation for this, we're comparing 0.08 to our new alpha, and our alpha now is 0.10, and that is given to us right here. A 10% significance level, that another way of saying that is your alpha is 10%. So 0.08 is less than 0.1, so from there you need to make your provide an explanation. So if your p-value is less than alpha, we're going to reject the null. So again, answer in terms of the question, and that's how you're going to set up the equations. 1014, it's going to be a very similar setup. You just have to do 2 calculations. So that's the one I really want to test you guys on to see if you understand the concepts. Try the best that you can, and then we'll go from there. If you guys have any questions, feel free to email me. I will host a Zoom session sometime next week or the week after, because next week is spring break, but I will keep you guys in the loop. Other than that, good luck, and let me know how it goes.